Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Packed columns, packing, types, application and selection. This course will be delivered in two parts. Part 1, understanding the characteristics of packing. Part 2, types, application and selection of packing and distributors. Packed columns, Part 1, understanding the characteristics of packing. In this video, you will learn packed tower internals, the steps in the packed column design, and the relevance of types of packing in the design process, characteristics of packing, and engineering requirement. I would appreciate if you subscribe to the channel. We are striving hard to deliver valuable knowledge content for your career progress. So subscribe now before you forget. Packed columns. Packed columns are widely used for distillation and absorption in refineries and petrochemical plants and oil gas industry. Packed column consists of packing material instead of trays to provide contacting surface for mass transfer. The packed column typically consists of two or more beds of packing over which the vapor and liquid are brought into contact with each other. This sketch illustrates a typical packed distillation column consisting of two beds, bed 1 of height Z1 for the rectification section and bed 2 of height Z2 for the stripping section. On top of bed 1 is placed a distributor to receive and distribute the reflux over the surface of bed 1. A redistributor collects and redistributes the liquid from the bottom of the bed 1 as well as the feed to the column. Both the beds are supported on packing support which is fixed to the column. So the packed column consists of four important elements: packing material, reflux and feed distributors, redistributors and packing support. The gas-liquid contact in a packed column is continuous, not stage-wise as in a plate column. The liquid flows down the column over the packing surface and the gas or the vapor moves up the column countercurrently. The performance of a packed column is dependent upon the maintenance of good vapor-liquid contact throughout the bed. This is an important consideration in packed column design. Not just the packing, but the method of distributing the liquid so that it wets the surface of packing material uniformly throughout the column is key to achieve the desired separation as per the design. The steps involved in packed column design. The design of packed column consists of four steps. 1. Select type and size of packing. 2. Determine the packing height. 3. Calculate the tower diameter. 4. Design the distributor, redistributor and packing support. For the design of packed column, the first and foremost step is the selection of size and type of packing. To select the right size and type of packing, you must know what are the characteristics of packing. Packing. Packing is material that provides contact surface for mass transfer between liquid and vapor in a column. The packings are designed and fabricated in varieties of shape and sizes. The objective of the packing is to maximize the efficiency for a given capacity at a reasonable cost. To produce packing surface with maximum efficiency, the design focuses on the following characteristics of the packing. The design and development of packing focuses on the following aspects. Maximize the specific surface area, spread the surface area uniformly, maximize the void space per unit column volume, minimize friction, and minimize cost. Maximize the specific surface area. This maximizes vapor-liquid contact area and therefore the efficiency. Spread the surface area uniformly. This aspect improves the vapor-liquid contact and therefore efficiency. Maximize the void space per unit column volume. This helps an open shape and has good aerodynamic characteristics. Minimize friction. This minimizes resistance to gas flow, therefore enhancing packing capacity. Having understood the packing performance requirement, let us move on to understand the packing characteristics. The most important factors for selecting packing material are surface area and void fraction. Other factors include packing factor, packing density. Surface area per unit volume of packing is expressed as meter squared per meter cube of packing layer. Surface area is designated as sigma. Sigma equals n times sigma naught. Where sigma naught is the surface area of one packing in meter squared per packing. N is the number of packing. Packing void fraction epsilon is expressed as meter cube per meter cube of packing layer. Epsilon equals capital V minus n times V naught divided by V, which equals 1 minus n times V naught. Where V is the packed volume of the column in meter cube. N is the total number of packing. V naught is the volume of one packing in meter cube. Another important packing characteristic is packing factor, Fp. Fp is expressed in reciprocal of meter. It can be expressed as a dry packing factor or wet packing factor. Dry packing factor is designated as Fpd is equal to sigma by epsilon cube. Note the dimensions of sigma is meter squared per meter cube and that of epsilon is meter cube per meter cube. Hence, the dimension of packing factor is 1 by meter. Wet packing factor FPW is a wet packing factor under irrigated condition. The packing factor is a unique characteristic of each packing size and shape. These factors, although determined by calculation from physical dimensions, they are determined experimentally for more reliable values. The packing factor selection significantly affects the performance of a packed tower. The packed tower capacity and efficiency can be modified in an existing column by changing the packing type and size. For a given type of packing, as the size increases, the packing factor decreases. As the size increases, the packing efficiency decreases and the pressure drop decreases. Manufacturers of commercially used packing provide values of packing factors for their products. Another parameter included in the packing characteristic is stacking density, rho P. It's equal to weight of packing per unit volume of packing, expressed in units of kg per cubic meter of packing. Selection of packing. How do you select packing for a given application? What are the engineering requirements? Let us find out. Packing to be selected for any given application should provide maximum efficiency for a given capacity and have sufficient mechanical strength for fabrication at a reasonable cost. From this point of view, the required characteristics of packing should include large surface area per unit volume of packing, large packing void fraction epsilon, low stacking density, good wettability, low fabrication cost, and enough mechanical strength. Having understood the packing characteristics, you are now knowledgeable enough to study, compare, and select the right type and size of packing for your application. The next video you will learn There are different types of packing and sizes of packing for any given application. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.